about to find out all about Kinesis Data Streams under the hood. So this is the 400 level talk and ANT423. So thanks for joining us, and my name is John Markle. I am a director of software development, and when I'm not speaking to nice people like yourselves, I lead the team that owns Kinesis Data Streams. And joining me today is my colleague Ali Alemi, and Ali is a principal data streaming architect, and he is going to be taking you through some of the finer details of Kinesis Data Streams, and looking forward to getting into it. So just a very quick overview of what we'll cover today. I want to just give you just a quick show of hands. I know this is maybe not everyone's favorite part of the talk, but who here has used Kinesis Data Streams? Okay, great. A lot of you obviously are going to be quite familiar with some of the terms, but just to level set, I'm going to introduce some of these concepts just so that we're all speaking the same language. And we're quite excited about some of the new features that we've launched in the last month that have answered a bunch of our requests that customers have been making of us. So I'm going to quickly go over the highlights there. Then I'm going to dig into a demo where we actually, this is great, it's a live demo. Well, it's a demo that you can download yourselves and run for yourselves. It was put together by Ali. And I'll talk through a real-world streaming application that demonstrates some of this new functionality that we've just recently launched. And then I'll hand over to Ali, who's going to take us through the real interesting parts of Kinesis Data Streams under the hood. So, what is Kinesis? Many of you already know. Fully managed serverless data streaming service. And with any data, with any streaming application, you collect and you process and analyze data in a real-time setting. And Kinesis Data Streams sets itself apart because it is serverless, it can scale, it's elastic, it is highly secure and highly available. The average streaming application looks something like this. So on the left-hand side there of this diagram, you've got your input for your streaming data. This could be click streams, it could be IoT devices, it could be mobile apps, it could be logs coming from your application servers, all sorts of different sources of data, and they could be on your production network, they could be on the internet, they can come from wherever. So all of this data gets aggregated into a single point, and these sources of data we call producers. So the producers on the left-hand side send their data to Kinesis Data Streams here, which is your aggregation point. And then it is consumed by a suite of different options here, but we've got services such as managed service for Apache Flink, Spark on EMR, Firehose, Amazon EC2, Lambda, if you want to write some custom code to process. And these consumer applications are sort of the heart of the streaming application architecture. And then, once you process this data, you will store that in some sort of a repository, either a data lake or some sort of an analytics database for you to be able to use and derive business value from. So, another show of hands. Who bought something on Amazon on Prime Day this year? Okay. So, like me, if you bought something, you were one of the people who pushed Kinesis Data Streams to a peak of 807 million records per second during Prime Day this year. To give you an idea of the scale of that, the global credit card transactions that are processed in a day, we could do that in about 3 seconds at this rate. So pretty phenomenal amount of information being processed through Kinesis Data Streams during that event. Every day, over the 3.4 million or so streams that customers have on Kinesis Data Streams, we process about 70 petabytes of data. And zooming in a little bit onto the scale of an individual stream, customers are sending as much as 10 gigabytes of data per second through one single stream. Now, that doesn't necessarily sound like a big number, but it's gigabytes with a big B. And that's about a 4K movie every second. So some serious data that we're talking about. All right. So we're zooming in even more from this very large, wide scale that KDS can operate at to the scale of a single Kinesis data stream. So you can have, on an individual stream, gigabytes per second of data of ingest, gigabytes per second of data of fan out and to your consumers. And then, as part of all of this data, you're processing potentially up to millions of records per second. And this can all be within a multi-tenant solution. So you can have different applications producing data and consuming data all within a single stream. So Kinesis Data Streams is what we call a foundational AWS service. And this foundation is underpinned by 4 pillars. So firstly, Kinesis Data Streams is elastic, meaning that it will automatically scale up and down as you need, as your load necessitates. It's easy to use, which is honestly one of the greatest parts of Kinesis Data Streams. You don't have to manage any infrastructure yourself. You don't have to worry about patching. You don't have to worry about network connectivity. All of that is taken care of for you because of the ease of use of Kinesis Data Streams. And it's reliable. So it operates in the small with very low latency, predictable latency, and you can scale that all the way out, and you get the same performance, the same performance envelope. So it's a really solid building block for any application to be built with. So, and then the last piece, as you would expect from any AWS service, it's highly available. So we architect our service across multiple availability zones. There are many redundancies that we have built in under the covers. Ali will touch on some of that just now. But you can, without having to think about any of these complexities, be assured that you've got the best availability that you can get for a streaming service. All right, now we're really zooming into the fundamental unit of a Kinesis data stream, which is the shard. So a shard is the atomic unit of scale. It's got very well-defined limits, so a shard can do 1 megabyte per second of writes and 2 megabytes per second of reads. We support about 1,000 records per second writes, 2,000 records per second reads. And this is the building block from which every streaming application can scale. So one of the interesting things about how a shard is used is you have a partition key, and your partition key is something that you specify when you write any data to Kinesis Data Streams. That is then hashed and distributed across your shards. So it is the mapping between your partition key and your shards is something that is automatically managed for you as your application scales up and down. And it's this level of indirection that really helps you build really horizontally scalable applications using Kinesis Data Streams. Now, there are pros and cons of having this type of a concept of a shard. It does enable, as we said, things like scaling. It's a convenient way to manage your capacity in discrete units, so you can pay as you use or pay as you go. It gives you this fundamental elasticity as far as when you're thinking about how much capacity you're using. But there are some of these challenges. As I mentioned, there's mappings between your partition key and your shards, and sometimes this is not obvious at first glance. There is also some complexity when things scale back in. When data gets redistributed across the different shards, where does it go? How do you handle that? We'll get into some of the ways that Kinesis Data Streams helps you there. And you can also have challenges where your consumers are potentially having an uneven load across them. So shards, although very convenient as a building block, are not a panacea, and there's some interesting things that we've done to be able to make them useful for you. So some of the things that we've heard our customers ask for on Kinesis Data Streams are, they don't much like managing capacity. Serverless obviously helps a ton with that, in that you're provisioning things in generally abstract units of capacity. But on-demand scaling was something that customers were really asking us for. And so about 4 years back, we launched the on-demand version of Kinesis Data Streams, where we would automatically monitor the amount of load that you were sending through to a particular stream, and we would add shards and merge shards as needed. This meant that if you had a traffic spike, an unexpected surge of records came into your stream, we would automatically add new shards for you, and you wouldn't have to worry about that. That would just happen transparently. The other thing that customers were also asking us for is the ability to write larger records to Kinesis Data Streams. So up until quite recently, as we'll go into, there was a limit of 1 megabyte for a record, and customers had to jump through some hoops in order to work around that. So the real benefit of the on-demand the on-demand version of Kinesis Data Streams is you had totally hands-free capacity management up till the top end of what we see with customers on streaming applications, which is about 10 gigabytes per second. This scaling happened for you automatically. You didn't have to set any kinds of thresholds or anything. It was just done as soon as you were using the on-demand version of Kinesis Data Streams. And you had the same performance envelope as you would normally have had if you were hand provisioning or hand managing your provisioned shards in the original Kinesis Data Streams provisioning model. And then the other advantages with on-demand, you didn't have to worry about shard hours and maybe unused shard. You were simply just paying for the data that you ingested, which was quite attractive as a pay-as-you-use model. So let's show you here in these CloudWatch graphs what it looks like to use either provisioned or on-demand mode. So you can see a workload here. We're happily handling, we have about 5 shards provisioned. We are happily handling a load of about 4 megabytes a second. And then there's a traffic spike. And you can see the amount of throttled records, which is the upper line there in that top graph, jumps up to about 60%. And now that's not good, obviously. You're dropping data on the floor. Now, in this case, what happened was we enabled on-demand capacity, which is something you can do for an existing stream. And you can see that automatically the system detected that that the load on the existing shards exceeded the throughput. It split the existing shards, it provisioned new shards, and the amount of throttled data on the ingress side drops down to 0. So this is super simple. You can see within a few minutes, totally hands-off, the scaling problem was addressed for them. So some of the challenges that builders such as yourselves have had that we've heard about building streaming applications are they want predictable performance at scale. They want to be able to have costs that are predictable as they scale up and down, especially, say, with spiky workloads. And they want the performance envelope to be quite consistent. These are all considerations if you're trying to build a streaming application. And one of the things that we launched last month is Kinesis On-Demand Advantage. Now, there are 2 key features that this new version of on-demand provides. The first is the ability to specify warm throughput. So if you know ahead of time that you're going to have an increase in load, instead of having to over-provision yourself and pay for potentially idle shard hours, you can just say, look, I'm expecting this amount of data to be coming in at my peak. So I'm just going to give you a heads up that I'd like to have this amount of warm throughput available for when I need it. So it's really simple to use. You simply enable the, you can either create the stream using the command line tools or in the console. You can just specify what you would like your warm throughput to be, or you can even specify this on an existing stream. So the second thing that is, as a feature, I think, of Kinesis Data Streams on-demand advantage is that it's about 40% cheaper than regular on-demand. Now, the reason that we've been able to do that is we did some work to figure out that with committed workloads, we were able to support this price point for customers that had all the reasons to want to use on-demand with the reactive scaling, with the pay-as-you-use model. But if you were able to commit to a certain amount of usage, we could then provide it to you for a much better price point. So on-demand advantage is really an interesting thing to look at. I would suggest you take a look at it. It's, you can take a look at that in the Kinesis Data Streams docs. The next thing that customers have had challenges with is large records. So a large record, if you needed to ingest data that was larger than a megabyte, typically what you would do is you would store it in in another data store, say AS3, and then you would store a pointer in your data stream to that record, and then your consumer would understand when it sees this pointer, it has to go and fetch the record. This presented a couple of challenges. Firstly, there's a bunch of complexity in there that you'd have to build into your consumers. Secondly, now the amount of data that's going in through a particular shard isn't actually representative of the amount of work that has to be done by a particular consumer. So you can get a fair amount of imbalance between your different consumers because these larger records are sort of opaque to the scaling system and the balancing systems. And you can end up with some pretty significant stalls in your consumer performance. So what we did was we added large record support where we've increased the maximum record size by a factor of 10. So you can now send records up to 10 megabytes in a single shard. It's super easy to enable. It's just a setting on your stream, and there's no additional cost to use it. And one thing that I'll explain here, which is kind of interesting, is how does this work with, for those who have been paying attention, the 1 megabyte or 2 megabyte read, 1 megabyte write, 2 megabyte read limitations of an individual shard. So how would I be able to write 10 megabytes of data to an individual shard with these throughput limitations? So I'll get into that in a second. So the way we actually do the throttling for an individual shard is with something called a token bucket. Now we keep a bucket of tokens where, as you're using per second your amount of throughput, we deduct from that bucket the amount of tokens that you've used, and we replenish it at a certain rate. Now in this case, these buckets replenish at a rate of about a megabyte a second. When a large record comes through and you consume in one big burst all of the available tokens, so in this case there were 10 tokens in this bucket, that's okay because that was able to successfully go through because we had that burstability, those microbursts allowances within the model that we still have for the hard provisioning on the shards. So you can see there that we've exhausted our bursting capacity, and we're able to continue to write at the 1 megabyte per second level. But what would happen if another burst comes through is because there are no available tokens in the bucket beyond the 1 megabyte per second that we already have, those would be throttled until you back off a little bit on your throughput. In this case, you can see we backed off to about 0.5 megabytes per second, and then that token bucket refills at a rate of about 0.5 megabytes a second. So a little bit of a subtlety to how to think about the large record feature and how it works, but we think this is a pretty seamless way to be able to use it. So one of the things that Ali and I thought was quite humorous when we were working together for this talk was we found out that we were both parents of twins. And it's an interesting thing to be working on on a horizontally scalable service such as Kinesis Data Streams and be a twin parent, we've had to both learn how to scale ourselves horizontally while our children have also scaled horizontally. So I'd like to take you through a demo to kind of maybe stretch this analogy a little bit far and show you how we can use Kinesis Data Streams to handle many things going on at once, such as the chaos that happens in my household. So let's imagine we're all building, we've built a new product and we want to do a launch. One of the things that is really good to do is to follow the social media sentiment of your launch. So what we've done is put together a social media sentiment analyzer. And I'll remind you that this is a demo that you can actually check out for yourself. It's on GitHub. I'll put a link to the demo in a bit. But the scenario is this. At 11 a.m., we're going to launch, make an announcement, and there'll be some amount of uptake. Then 5 past the hour, a celebrity picks us up and reposts it. And all of a sudden, the activity around this launch starts to mushroom. And eventually, we reach this viral moment where about 45 minutes after launch, we're seeing an insane amount of engagement, and our poor little social media analysis streaming application is really trying to keep up with all of this. And then eventually, the hype bubbles down, and we're back down to sort of a baseline of traffic. So that's what we need an architect for. So let's take a look at how we would do this. So on the left-hand side here, we've got our event producer. This will be the data feed from the social network. We're feeding this data. So the producer of the data is sending this data into Kinesis Data Streams. We then have a stream processing consumer here, which in this case we've built using Lambda. This could be doing all sorts of things like using a large language model to do the sentiment analysis for you. And then we store the data results in a data lake later for using for analytics and for also triggering for sort of further events. So we'll use data firehose to put this data into Amazon S3 tables. So this is phase one after the initial launch. We're seeing about 100 messages a second, nice and easy to handle, nothing too bad. We're well scaled for this particular load. And I'll just show you here the results of a list shards API call. You can see we've got 4 shards open. Everything's going great. Now our celebrity picks us up, and their followers are alerted to this launch. And you can see what happens is we see this pretty significant increase in engagement, and our sentiment analyzer is, well, what's actually happening is the incoming records are actually being dropped on the floor because we're seeing more input from our producers than the stream is scaled to be able to take. However, we are using on-demand, so the stream does scale up automatically, and eventually the throttling records subsides back down to baseline. You can see here that the original 4 shards that we had, those were split, and we created some new shards, which is great. You know, this is all handling the scaling for you. And as we hit the viral moments, we split those shards even more. We end up with the peak of our sentiment records coming in, and this particular workload is now scaled up to about 50,000 records per second coming in of social media posts that we need to analyze. And so by the end of all of this, we've automatically scaled the stream up till 128 active shards, but you can see all the shards that we've split there and closed. So all told, we processed 55.1 million records, but unfortunately we dropped 2 million on the floor. So there was a bunch of data that we lost. Unfortunately, in this case, due to the initial scale not being enough, this is how our social media sentiment analysis application fared. Now, if we were to do the same thing using on-demand advantage with our warm throughput, what we can do is we can go into the console and we can just specify what we would like in terms of warm throughput for the stream. It's just a setting, and you specify it in megabytes a second. There's a really neat tool here, though. in the console where you can actually use either test data or even production data, and you can get an idea of what you should be setting your warm throughput to. So you can say, well, I expect this much load, what should I set it to? And so this helps you through that process, which is quite handy. So we start doing this with on-demand advantage, and you can see we start out the gate with 128 shards. Even though we've got a very low amount of traffic at the beginning, and we see our traffic spike up when the celebrity shares this on their network. And as we get to the end of the result here, we were able to process 57.2 million records. We didn't drop anything on the floor, and we got a much cleaner signal from the social media analysis. And you can see that we didn't create any new shards. We were perfectly adequately scaled up to be able to handle this load. And I think that was kind of a really interesting demonstration of how warm throughput can help you with these business events that you can anticipate, such as a launch. As I mentioned, this is available on GitHub. If you're interested, you can take a snap there of the QR code. You can check it out. You can run this for yourself. It's a really, really interesting example of how on-demand advantage can make your peak events a non-issue for yourself. Great. I'm going to hand over to Ali to take you through the rest of the under the hood details.
Wonderful. Thank you very much, John. Awesome. John mentioned a lot of amazing features about Kinesis Data Streams. As John mentioned, I'm a streaming architect with AWS, and I work with customers every day. Very often, I help them to set up, configure, and fine-tune their self-managed streaming storages according to the best practices so they can scale when they have a large event, so they need guidance sometimes, and then we help them to scale their infrastructure. Very often, scaling from 1 gigabyte per second to 10 gigabyte per second needs weeks of planning. And it became a point of curiosity for me, how Kinesis Data Stream can do that without operators doing anything. That's very interesting. So I had a conversation with engineers. I reached out, and with John's permission, I got connected with some of our amazing folks, and I asked, can you walk me through how you designed this system, how this is different? They shared a lot of under-the-hood facts with me, and I'm here today to share all those under-the-hood details with you today for the first time. Just a refresher to John's part, Kinesis Data Stream principles are, it should be easy to use, it should be highly available, secure, durable, with low latency at the very largest scale. Millions of data streams, and also hundreds of millions of requests per second. Engineers shared with me, one of the first difficult decisions they needed to make was how the system should scale. Well, John mentioned that shard is a unit of a scale, and then we horizontally just scale up, right? Easy. Is it? Well, so one implementation, which I know other streaming storages also work like this, is to just simply add shards, right? So we have shard 1, and then we just add another shard. How many problems are you able to identify with this? 1, 2, 3. I identified 3. For 1, what I'm showing on the slide, you can see that the messages could get out of order. Why is that? The messages have the same key, by the way. Well, why is that? So if you pay attention, when we introduced the shard, there was a part that shows the producer uses the hash algorithm to encrypt the key with the hash algorithm. And then depending on how the hash algorithm divides into ranges, and then each range maps to each shard, the message will belong to that shard, will be sent to that shard. That's how the system distributes messages, right? What happens when we just go from 1 shard to another, to 2? Well, the shard range splits. Then the messages were all belong to 1 shard range, now could belong to another shard range. So then message C with the same key could end up in a different shard. Consumer will read them out of order. Problem number 2, how we are supposed to scale back in? Can we just go from 2 shards to 1 now? No. What are we going to do with the data? Are we going to just read that data, somehow merge it into another shard? We can't do that. And then there is another problem. Well, so when we want to even balance this load on the backend nodes, and I will talk more about the backend nodes later, then we end up with shards with so much data in it. Like a shard could get easily to 10 terabyte, even more. How we're going to be even balance this load across different worker nodes? Then we need to copy that data all over from one node to another, and then from one node to another. It takes a lot of resources, it takes a lot of time, and it's violate the principle that I mentioned. It should be predictable. So engineers were very innovative in the approach that the way that the shard actually scales. So the shard, the Kinesis Data Stream just does not add another shard. It splits the shards. What it means that the active shard, aka parent, will close. 2 new shards will be added, aka children. And then the consumer first read the messages from the parent, and then it goes and read messages from the children. So when we take a screenshot, when we describe shards of a stream, this is how it looks like. The parent shard is closed, 2 new shards will be open. And same way, when we want to scale back in, then 2 previous parent shards close, and then the children shard will be added. All the messages from the producer will come to the new shard, the children shard, and then the parent shard close. The consumer can consume the messages from the parent shards until they're finished, and then we can split again, and then we can merge again. One good thing about this architecture, as you might have guessed it, is, first of all, it solves the problem of messages not getting out of order. With this approach, we can scale back in without any data loss, without any problem with message ordering. And then number 3, each of these shards could be in a different worker node. If we have a shard that does not split, does not merge, and then the size is reaching some limit, we can decide to close it and then move the rest of it and open a new shard and move the rest of it to another worker. So then we don't need to copy the data all over because we are doing it all, even load balancing on the back end. So here's what happens. The workers are actually those storage nodes that they persist your data. And then because the workers are in 3 availability zones, you see the 3 columns for them. And then once a shard closes, then a new shard could open on a different worker with the replicas on other workers, and then the data will go there. And then the previous shard is there, but it's closed. The producer cannot write data to it. And then the new workers accept the write, and then the reader will first read the parent shard and then comes to the children shard. So another principle that John mentioned is that Kinesis Data Stream must be highly available. High availability means that for any copy of data that you're writing to Kinesis Data Stream actually stores 3 copies of it and then puts them in 3 different availability zones. Why? Because each availability zone is a containment zone of a failure. So then the data will end up in 3 availability zones. At the event that we lose the entire availability zone, still 2 copies are available. So with the previous architecture that I mentioned, and also the fact that the nodes are replicated across 3 availability zones, there is some complexity. One of these nodes always going to be the leader, the node that accepts the write, and then 2 other nodes going to be the replica. When a consumer and a producer want to read or write, they need to connect to that node. They need to find a way to connect to that node. Therefore, they need to do a discovery. They need to find out how to connect. What's the DNS record? What's the IP address? How to connect to it? And then they make a connection. And then if the replica or leader fails and then another leader takes over, they need to also know that and then make a new connection. So that violates another principle, that the Kinesis data stream needs to be easy to use. Therefore, engineers built the entire front-end fleet and abstracting all that complexity away from customers by exposing a single API. Through a single API, you would be able to collect data across various sources and then bring that into your network infrastructure. So you don't have to manage network infrastructure. You don't have to worry about the scale of that infrastructure. You don't have to worry about any DDoS attack or any bad action that could happen for the APIs that you need to build, and that API is available. And that API takes care of auto-balancing and load balancing that data across multiple availability zones. So now that it's the responsibility of the Kinesis data stream to figure out how the request that is coming in from a customer get routed to the backend nodes. In order to do that, engineers had to build 3 internal services that is hidden from you. Cache service, a membership service, and a timer service. We'll talk more about those. There are some customer responsibilities as well. The consumer and producer responsibility is to be aware of the shards, to know that each Kinesis data stream has shards underneath, and then for a producer to load balance the data across many shards and not exceeding the limits of the shards, and then for the consumer to be aware of the processing threads, which one is reading from which shard, and doing some sort of a process that we call it the lease management. But we'll talk about that more. Kinesis data stream will continuously monitor all aspects of the backend nodes. If you add another consumer with other streaming storages, you need capacity planning all over again. Because you need to make sure there are enough network throughput and disk throughput to sustain the throughput that is coming in, and still have buffer for all the background operation, and also have enough capacity for an additional consumer to read the same data. With Kinesis data stream, you don't need that because Kinesis data stream has a feature, enhanced fan-out, that recently made a new launch to support up to 50 distinct consumer groups off of a single Kinesis data streams. So let's talk about that API layer a little bit more. So for those of you who raised hand and said you're using Kinesis data stream, thank you for that. But then the chances are the data that you're writing today is stored on the same node as somebody else in this room today. So the API needs to make sure every request that is coming in is authenticated, and the user who's trying to access has access to access the resource that is indicated, and also make sure that it's not exceeding the quota, overdriving those backend nodes, and also making sure that and then encrypting the data with the keys to encryption in transit or TLS, and also making sure that the data is encrypted with the customer managed key or with the AWS key on the backend. And then also, if you have a requirement for using IPv6, a single API as part of a dual stack APIs will give you IPv6 or IPv4 through AWS SDK. You can enable that. If your requirement requires or you're required to use FIPS endpoints, in the US Gulf Code, you can access Kinesis data stream with FIPS endpoints, so you don't have to build that. If you want to do access control, you have access to the resource-based policy for controlling the access to the resources at the stream level, and also you have access policy through the IAM identity in AWS Identity and Access Management, or AWS IAM. So the front-end service, each of those front-end services do that hundreds of millions of times every second. Let's see how it does it. So these APIs need information regarding with which member wants to access which resource, and then which shard belongs to which stream and which member. So that information also, could look like this. Also indicates who is the leader node, who is the replica node, and then that's how the routing happens when the request comes in. So a naive approach is to just store that in a database, and then every request that is coming in, we just go and load with the shard ID or with the Kinesis stream ID, and then load that information from database and then find which node we need to route the request, and then we do that. Well, we know this design doesn't work. Why is that? Because if we are building Kinesis Data Stream for a massive scale, then we need a database service even bigger than that, because we need to make sure that the service is reliable. Also, the latency wouldn't be very low, because the databases tend to have, double-digit, latency, and then the API latency will be even higher than that. So like any other engineer that would say, let's put a cache in front of it. Would this work? Well, this definitely improved the performance, but not always, because what if the cache fails? Then we need also a cache service that is giving us, with the capacity that is even bigger than the Kinesis streams, and also the cache could get out of sync with the database for a variety of reasons. So engineers went back to the basics of how a database actually works. If you think about it, what a database does for us is gives us a consistent view or a snapshot of all the change logs. For all the change logs that are coming through, it will give you always the latest and accurate snapshot at the time that the read occurs. So engineers thought, what if we just replicate that to all the different components, the front-end host and also the cache layer. So then each of these components independently can build that snapshot. So then when the request comes in, we can just read that information from the cache in the memory of the worker. Does this design work? Those who think this works, raise your hand. Great. Not quite. We are getting there, but not quite. So the problem with that design is we are operating a distributed system, and then this distributed system could go out of sync for many reasons. Node could fail, change log could be replicated, get processed twice, could get processed out of order, the system could get out of sync, and then it wouldn't work. So for that reason, engineers added additional information to the shard map entity to indicate how long this record is valid. So if a node has any record, it also checks if this time has passed, and if this time is passed, then means this record is stale. So it needs to go and get the new record. All right, so let's put that in place. Does this design work now? Raise your hand if you think this works. Okay, still one more wrinkle that we need to iron out. Well, the time runs differently, turns out, across distributed systems. So when they want to compare the time, they should compare with a reliable clock. What is the reliable clock? Is the system time at different components reliable enough? No. Milliseconds matter here. We are talking about hundreds of millions of requests every second. And if you get a request that is going to the wrong node and you get an error and then you have to retry again, that's not a reliable system. Therefore, engineers built another service called timer service. So a timer service is the source of truth for the time across all these different components. Doesn't matter what system time they're showing on their system, they need to compare that time to live, with the timer service. And they constantly poll the timer service in order to refresh that, and then they will use that to compare with the time to live. And then if that record is stale, then they will go get it from the cache. If it's not in the cache, then they will go get it from the database. Okay, one last thing. Does this design work? Those who think this works, raise your hand. Well, that's what you got, so this works. All right, so with that, let's talk about the consumer responsibilities. As I mentioned, consumers need to be aware of the shards, because we are processing the data in a distributed way as well. So there are certain aspects that the consumer needs to manage. For one is the state of which processing thread, which worker is consuming from which shard. So then the mapping between the shard and the consumer's instances or consumer processing threads needs to be kept somewhere, and then that needs to be constantly monitored and managed. So there are some best practices for consumers. If you're writing your own consumer application from scratch and you want to write your own client library, make sure that you do proper handling and make sure that you monitor your clients and you are doing a good job of keeping the track of the estate. If you're using any of these native services or third-party applications, there is an integration already there between Kinesis Data Stream and these applications. So because of that native integration, you don't have to write any code. And as soon as the data lands in a Kinesis Data Stream, you can consume it using any of these services or third parties. And if you need to write code and you do not want to use AWS Lambda for that, then Kinesis Client Library takes all the heavy lifting, all the estate management. So unless you're really interested in doing this, Kinesis Client Library is the easiest way to package it with your code and write a custom code to consume from a Kinesis Data Stream. And recently, Kinesis team released the version 3 of Kinesis Client Library. How many of you were aware of Kinesis Client Library version 3? Great. How many of you have moved to version 3, upgraded to version 3? Okay, so if you haven't done already, it's the best time to do it because there are so many enhancements in it. One of those enhancements, my favorite, is that it detects which one of the processing threads are overloaded, and then it even balances. It basically takes the least from one, and then it can override and take the least from one worker, give it another one. It even balances the load across workers. That will return to you cost benefits. All right, going back to this. So when you use Kinesis Client Library manages the state across 3 separate DynamoDB tables. The state table keeps track of which one of the workers is leader. The least table keeps track of which one of the workers and processing thread is consuming from which shard, and then how that subscription and mapping looks like. And then there's a metric table that uses in order to Kinesis Client Library version 3 uses in order to know which one of the workers is overloaded and then even balance it. It also emits all the client-related libraries to Amazon CloudWatch for you, so you don't have to worry about that integration as well. It has components to do that. So on the left-hand side is the worker, which is in charge of polling. There is on the right-hand side the processing threads, and these threads are decoupled from each other. So those who have done multi-threaded programming know how difficult it is to run a multi-threaded programming without any memory leak and other issues. And then there is a scheduler, which is acting as like a timer, runs everything. Here is how a list management record looks like. It has a key, it has a checkpoint. So each of the processing threads, as they progress, they frequently checkpoint, and the checkpoint information is stored in the list management table. And it also has a lease expiration time similar to the time to live. The purpose it serves is very crucial. When a lease record is not updated, means that this timestamp is not up to date. It means that the processing thread has failed silently. And it detects it, and then the other worker will take over it. And then whoever wins, which one wins? The first one, obviously, who takes the lease. That one will take over from another worker. What if when the leader fails? So when the leader fails, another worker basically will take over. And then if a worker fails, the leader could take a lease from the previous worker and give it to another worker. So that's how a distributed system and a stateful distributed compute system should work, and it works with Kinesis Client Library. So let's talk about the producers now. Producers also need to be aware of shards in a different way. Is it efficient if a producer for every single record makes an API call? When I speak with many customers, they acknowledge that it's not efficient, but they do it anyway because they think they get the lower latency this way. Turns out network calls are not cheap. Network calls are not free. Network calls have overhead, as I mentioned. Every single request needs to be authenticated, check for access control, check with the access limits, and then routed through. So if you're sending one request for every single record, and by the way, that record is very small, you're not using it efficiently. So we recommend customers to batch up the records into larger payloads, and then also, if it is possible, send those larger payloads in batch as well. Kinesis Data Streams have two APIs for writing records. It's put record and put records. So we recommend anytime possible you use put records API in order to send multiple records with a single network call. And then within put records, you can put up to 500 records. What if the record, and what should be the size of that record? We will talk about that more. If you're using these native services or those third parties, there is a native integration, there are native connectors that will help you to write data to Kinesis Data Streams. So those best practices are already built in. But if you are writing your own code and you want to call the APIs, make sure that you also do aggregation if you have very small records. We recommend the record size should be somewhat around 10 kilobytes. If your record size is way smaller than that, one of the techniques is to build larger payload out of a smaller records. So let's say we have clickstream record, which is only 400 byte. So we aggregate them into a 10 kilobyte batch, and then we can even compress that. So we can even pack more clickstream records and then compress it to become somewhat around 10 kilobyte, and then we can use the put records in order to send all of that in one network call. Although it is counterintuitive, you will get better latency and you will get better throughput this way. Because if you have a very large throughput of clickstream data, which is small, the network overhead is going to be the one that acts as a bottleneck for all that throughput to move through the pipeline. And if you do not want to be worried about these best practices, and if it's always been followed, if you do a implementation of them correctly, you can use Kinesis Producer library. That's another library, which is, by the way, open source, and I'll provide the link in a moment, that you can use in order to aggregate all the smaller records into larger batches, even compress them, and there are options that you can enable or disable. And then you can also put them into, once you put them in the larger batches, then it has a buffer to buffer them, and the buffer is reliable. If a node fails, then it has a system that you can basically make sure that the records are there. And then the collector and the retryer and limiter will help you when you hit the throttling. So then it retries to make sure that the buffer gets flushed into the Kinesis data stream. With limiter, to make sure that you're not exceeding those quotas. You're not exceeding the limits that the Kinesis data stream imposes. And then it emits those metrics in terms of how many records get throttled, how many records went through, how many records were successful, what's the latency of the pipeline and everything into Amazon CloudWatch. And then it reliably can work across many of the instances of your producer. So I will leave you with additional resources here. If you want to get more familiar with the Kinesis data stream, and you want to get more details, you can go to the first QR. The second one is the demo that we shared with you today, so that will take you to the link to the GitHub to try out the demo. And if you want to get more information in terms of reading the code or finding the project of the Kinesis Producer library or Kinesis Client library, you can go to those two on the right side QRs. That will take you to the GitHub, and you can check those out. So what I would like you to do is, after this session, try out our demo and see how Kinesis Data Stream can deal with the peak of going from 10,000 to 100,000 or 500,000 or even millions of records per second, and monitor the whole pipeline in a live demo in your environment. That comes with a lot of best practices that we shared today, and you can reuse a lot of those components. If you're writing similar application, you want to build a serverless pipeline that it all scales out by itself, using that as a baseline for your projects. And then another call to action is please, 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 you will receive a link from the survey, and please fill out those surveys because those are really important for us. We use your feedback in order to improve the content, improve these sessions for the future, and those surveys are always important for us. With that, I would like to thank you all for coming today, staying late with us tonight, and sitting through this presentation. Thank you.